Welcome to week four, week four of programming with C++. Now, in today's video, we are going to discuss about expressions and statements. Expressions and statements. So, statements and their types, expressions and their types. So, let's get right into it. So, what are expressions? Expressions are a combination of variables, operands, and operators. Now, variables they store value or results of expressions, and operands are the entities that operators act on, and operators are mathematical symbols or arithmetic symbols like addition, subtraction, division, modulo, etc. So, an expression may be mixed, right? May be mixed, it may consist of one or more operands, may consist of zero or more operators to produce a value. So, meaning that a single operand, let's say C, when you have C alone, it can be an expression. When you have A plus B, it can be an expression. When you have X is equal to A plus C, that is also an expression. Now, let's move on to types of expressions. So, under the types of expressions, we have the constant expressions, the integral expressions, the floating expressions, the pointer expressions, logical expressions, and relational expressions and bitwise expressions. So these are basically the types of expressions we have. Now let's continue. So if all the operands are integers, that is an integer expression. If all the operands are floating points, that is a floating point expression. If um, an integral expression will yield an integral result as well as a floating point expression will also yield a floating point result. So it's basically you reap what you sow. So um when you sow integers, you reap integers. Yes, when you sow floating points, you reap floating points. So that is that. So let's move on to mixed expressions. Now for mixed expressions, um that's basically a combination of different data types. So we can combine integer and floating points. Yes, so when you see an expression with different data types, that is a mixed expression. So examples are over here: 2 plus 3.5, 6 divided by 4 plus 3.9, 5 point 4 times 2 minus 13.6 plus 18. Yes, those are mixed expressions. Now we have conditional expressions. Now conditional expressions, um, the expressions where the value produced depends on the value of a condition. That means there is a certain condition that has to be met before a value will be produced. That is conditional expressions. Relational expressions, they yield results of type bool, which takes a value true or false. They yield results of type bool, which takes a value true or false. So an example is what has been stated here, right? X is less than or equal to y, comma, x plus y is greater than 2. That is a relational expression. Then we have logical expressions. Now, logical expressions combine two or more relational expressions and produces bool type results, right? So we know that the bool type or the bool data type heavily relies on true or false, or basically true or false. So the logical expressions combines two or more relational expressions. We've already come to see or know what relational expressions are. So it combines them and produces a true or false result. So depending on the outcome, the answer or the value or the result will either be true or false. Pointer expressions. Now pointer expressions produce address values. So from our previous week we studied or we um did pointers. So they shouldn't be new, right? They shouldn't be new at all. So examples are below. Pointer expressions will produce address values. You know what pointers are? Pointers point to the address of any variable they are pointing to, or the value of that variable they are pointing to. Ending expressions. Ending expressions um, tell the system that you are done with your expression, instruction, or expression creation. So a semicolon is basically used to end any kind of expression in a C++ program. So the semicolon, which is also known as the termination symbol, right, is basically used to end any kind of expression, any statement, anything at all in C++. If you want to end what you are doing, whether expression, whether statements, etc., you use a semicolon. Now, an example of ending expressions has been illustrated here, right? So this is a basic code where, um, as you can see, using namespace std, he ended with a semicolon. That is an ending expression. Also over here, int age is equal to 12. He ended with a semicolon. That is an ending expression. If you remove or omit the semicolon over here, your code may not run. In fact, your code will not run. It's not a matter of me. Your code will not run. There will be errors in the code. So that's how important the semicolon is, the ending expression, right? So over here, so string x is equal to AMA. We ended with the semicolon here as well. See, yes, so semicolons are very important in C++. Now comments are very useful in writing code because when you say you're writing a code, maybe a very lengthy code, you would want to keep a documentation of what you are doing. You would want to keep a documentation of what you are doing, so that's where comments come in. So for any block of code you write, you can introduce a comment. Maybe you are writing a block of code to add two numbers, right? You can indicate that through commenting. Can indicate that through comment. Now, how does commenting work? Well, we have single line comments where in order to comment, all you need to do is bring a double slash in front of the text. In front of the text, you just bring the double slash, or if it's a code you want to comment, you just bring a double slash in front of the code. And we have multi-line comments where that is used to comment a paragraph. It's used to comment a paragraph or more than one line. More than one line. How does that also work? Or you introduce a slash and an asterisk, a slash and an asterisk, a slash and an asterisk. So you start and you pick the paragraph or the line of code in which you want to comment. Then you put it in front, so a front slash and an asterisk in front, and then where you want to end, then you also put a front, sorry, yeah, uh, an asterisk and a slash. Okay, so doing so, your C++ compiler will ignore any text between the beginning slash and asterisk and then the ending slash and asterisk. Okay, so let's see an example of multi-line comments. Let's demonstrate that. So I go to my code blocks now. Let's say I want to add two numbers, right? I want to add two numbers. So let's first initialize these two numbers. So int a, int a, let's go. So sorry, let's a 5 10 b 7, right? Delete it. Okay. So now um, int results, or let's go with sum. Let's use sum. Int sum. Yes, since you're adding int sum, right? Okay, so now see as some. Let's first comment this so that I can quickly show you how it's done. Okay, so before we even complete this code, as I was saying, if you want to begin commenting anything at all, or you want to apply commenting to your code, you can either do it when you want to keep documentation of what you are really doing. So in this case, we are adding two numbers. So I can just, before I even start, I can just come here, then double slash. Since I'll be using a single line commenting here, I'm just writing a simple statement. So a double slash, then I'll go with adding two numbers, right? Yes, adding two numbers. Let's call it right numbers. Okay, let me correct it. Numbers here. Numbers. Okay, so adding two numbers. Now I have commented what I am doing. I have commented what I am doing. Right. So let's go on ahead to finish this code. So as I said, we are adding two numbers. We are adding two numbers. So let's go on ahead. Sum assignment operator, or in this case equal to, since this is basically a simple algebra or linear algebra, so we are just adding two numbers. So this is a simple linear equation. We are adding two numbers. So a plus b, in this case we are using the a plus b because that is what the system recognizes, not the values we used. So a plus, then we end it. You see how I am carefully ending everything with a semicolon. Yes, ending expressions, semicolon, a semicolon. I'm highlighting it so that you see. Okay, so now what will the system give us? So we are instructing the system, sorry, we are instructing the system to display our answers for us, or our answer for us. So the sum, go with this. Okay, okay. So what we've done here now is we commented, right, that we are adding two numbers. So this commenting. Now we initialize the variables a and b to be 5 and 7. We are adding them. So we also, since the result should be an integer value, we need to also allocate a memory in the system for the sum of those two numbers. So we declared sum as an integer. Then we performed our expression. This is an expression. You can see this is an expression. Sum is equal to a plus b. It's an expression. It's an expression. Yes. So we also introduce our expression over here. Now we also make sure to end with a semicolon in each case. We end with a semicolon in each case. Now see out sum, then our sum over here. Now this sum, right? This sum is the value the system will give us. You can see as I highlighted it over here, it's also highlighted all the instances where sum appear, right? So it means that this line of code, right, where we are instructing the system to output the sum at the console, right, will output whatever value 5 plus 7 will give us at the console. So let's do that and see. So we can see our sum is 12. Our sum is 12. So that is commenting, right? We can also comment any line of code. So for instance, we can comment, you can choose to comment just this line of code, right, by single commenting it or single line commenting, yes. Or we can comment everything here. It's everything here by using multi-line commenting. Multi-line commenting. So as you can see, it just instantly commented entire thing, the entire thing. See, I started here. Let me. I started here, right? I did the the beginning aspects, right? The slash and the asterisk. Then I came to end it here. So that's commenting and all about commenting. Yes. So let's move on. Indentation. Indentation is basically makes code more readable and easier to understand and much more pleasant. So one thing you should notice that if not done properly, if not done properly, that is indentation. If your indentation is not done properly, your code may not run. Your code may not run, or you may find errors in the code. So that is how indentation is done. Over here, uh, the variables a and b were initialized, then a condition was given. Now, as you can see, if you look at my code, right, you don't see any indentation here. I prefer not to use indentation, right? I prefer to go the normal way, right? But if you prefer to use indentation, then it means that after every line, right, your the next line of code will be indented, right? It will be indented. But if you don't indent it well, that can also cause you problems, right? If you don't indent it well, that can also cause you problems. So as you can see here, the cout was pushed in further, right? But if you check let me uncomment this. If that is even a word, let me uncomment quickly, okay? As you can see, my cout, see if you check my ints, the first line, the second line, third line, fourth line, they're all in sequence, right? None is pushing in. But if you check here, since indentation has been applied here, this is pushing in, the cout is pushing in. So that is indentation. And let's move on to statements. Statements is a single or a statement is a single instruction that performs an action. It's a single instruction that performs an action. So um let's move on to types of statements. Right, we have iterative, we have selection statements. Selection statements. These basically are used for decision making. These statements are used for decision making. We have iterative statements. Iterative statements are used to express iteration of tasks, right? We are used to express iteration of tasks, and then expression statements are used to evaluate expressions. So to shed more light on the iterative statements, they are basically used for loops. In C++, there are you know something there's something called a loop. There's something called a loop or loops, right? For, while, do, while, they are all loops. Iterative statements are basically used for loops, or they are used in loops. Now let's move on. Declaration statements. Declaration statements, they are used to introduce new variables or constants. They are used to introduce new variables or constants. So we've seen numerous examples of declaration statements. There is even an example in the code we just showed. It's a declaration statement in sum, then our semicolon is a declaration statement. Jump statements are used to manipulate normal execution of codes. They are used to manipulate normal execution of codes. So these are used in switch statements. We'll get to that. We'll get to switch statements. And we have compound statements. They are basically statements that group multiple statements together. They group multiple statements together, and they are also enclosed in curly braces. They are basically like blocks of code. and enclosed in curly braces. So an example is what you see down here: a curly brace here, curly brace here, and then a block of code in between. Block of code in between. So this block of code we have here is a compound statement. Now let's move on to selection statements. They are used for decision making. So we have if statements, if else statements, switch statements. These are called selection statements, and they are used for decision making. They are used for decision making. Now, if you can see, I'm about to highlight something. Look at this if statement. Now, the if for the if statement, there will be a condition, right? Once you know type if, you need to introduce a condition. That's the if statement, as well as the if else. Once you type if, you need to introduce a condition, and then you bring the statement, then you carry out your else, then you bring another statement. And then also for switch, you bring your condition as well, and you carry out with your statements. So let's move on to if statements. Let's move on to the if statements. Now, what is the syntax of an if statement? As I mentioned earlier on, right? It's basically your if, and then the expression or condition, then your statements, the if, expression or condition, and your statement. So let's look at this particular example. So over here, a variable age has been initialized, right, to be 20. So age is 20. Now, an if statement is being used here. So if, then condition or expression, then statements. If, condition, statements. Statements. Good. So that is basically the syntax for an if statement. So let's put that into a practical aspect so that you can see. So let me quickly comment this. So now we're dealing with an if statement, right? So let's initialize age. Let's see over here the age is 18, 18, 18, right? So number one ahead. So what do we want to do? We want to use an if statement. So if truly, we don't actually type truly, it's just just so if the age is less than or equal to, yeah, let's use less than or equal to, okay, so less than or equal to 18. So let me break it down. We initialized age as 18, then we gave a condition over here that if age is less than or equal to 18. So we come down and then we write our statement. Now note that our statement will be enclosed in the curly brace. Our statement will be enclosed in the curly brace. Remember compound statements. Compound statements are what are enclosed in curly braces. And compound statements are a combination of what, two or more statements, or more than one statement. So if age is less than or equal to 18, see out. We want our system to display this in the console. So see out, um what do I use here? Okay, see out. Very young, yes. Let's go with very young. Let's go with very young. Very young. Very young. Okay. Very. So what you've done here is that, as I explained earlier on, we've initialized age as 18. We give a condition that if age is less than or equal to 18, then our system should display this message very young, right? Now in this case, since our age is 18 and we are over here saying less than or equal to 18, this message will be displayed. This message will be displayed because the condition is considering the fact that the person can be 18 or below 18. So as long as the person is 18 or below 18, you should get this message very young. So when we output or when we, yes, when we output it, we should get this message very young. This shows that it is what following the condition we gave it, right? So let's go on ahead. So yes, as you can see, very young, right? It is obeying the condition, right? That is an if statement, an if statement, an if statement. Now let's go on to, or let's move on to if else statement. If else statement. Now for if else statement, it's basically an if statement, but with a twist. It is basically an if statement, but with a twist. So basically it follows the same syntax as an if statement, but in this case, after stating your initial statement, right, you now introduce a condition whereby, should in case the initial statement is right or wrong, then the else statement should produce um an outcome that is either right or wrong, or vice versa, right? So let me explain that practically. Okay, you let's first look at this example and I'll explain that practically. So in this example, uh, age was initialized as 12, right? And then they gave a condition over here that if age is greater than 12, then the student is old. If age is greater than 12, then the student is old. That is the if statement. Then they came down to give the twist else, meaning that if the student is not 12 years or greater than 12 years, okay, in this case they use only greater than. So if the student is not greater than 12 years, then the student is young. That is what the else here means. Okay, so if age is greater than 12, student is old. That is the if statement. Else, if age is greater, if age is not greater than 12, then the student is young. So anything aside from being greater than 12, the student is young. That is what this means. So let's put that into practical use with our already written code here. So over here we are saying that if the student is less than or equal to 18 years, then sorry, if the age is less than or equal to 18 years, then the the person is very young. Yes, the person is very else 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 else. Now for the else, and did I talk about the syntax of the else? Okay, I can talk about it here. Okay, so for the else, right? Once you write your if statement, your initial if statement, right after you where you end with the curly braces, the closing curly braces for the if, then you continue your else statements from there. Now the else statements will also take another um curly braces, another set of curly braces. What do I mean? What I mean is that the after you write your else, right, the statement that would come after that will be enclosed in curly braces. So look at this. I've written my else, right? Then The next statement will be enclosed in curly braces. So see out else what should we, okay, very old, yes, very old. If they are not young, if they are not young, they are old. So see out very old. Okay. Then yes, so now what you are doing or what you've done here is that we said um if the student is less than or equal to 18 years, then they are very young. Else if they are not less than or equal to 18, then they are very old. That is basically what you've done over here. So right now, in order to see if this code is actually working, let's try changing this the age over here. Now we are saying that if they are less than or equal to 18, then they should be very young. But in this case, what if they are 19? What if they are less than or equal to 19? How about that? Or okay, you let me rather make it greater so that to be very simple. What if they are greater than 18? Yes, greater than 18. So that we don't have to change the value greater than 18. Okay, so what if they are greater than 18? Let's see what happens. What if they are greater than 18? Let's see what happens. Let's see what happens. Let's see what happens. Very old, right? So it means that our if else statement is working, right? In this case, the age was greater than 18. So the if else statement was considered. The age is very old, right? Or the person is very old. So that is it for if else statements. Let's go to nested if statements. Now for the nested if statement, it is basically an if statement in another if statement, an if statement in another if statement. So basically an if statement in another if statement. So if we look at the syntax provided by here, we can clearly see it. So an if statement with this expression, another if statement with this expression, right? So the first if statement can be considered as an outer if statement, and then the second if statement can be considered as inner if statement. Then you introduce your statements standards. Yes, your statement standards. So let's look at uh, a practical example over here. So okay, let me demonstrate this practically over here so that you see. So let me comment this. Let me comment. Or should I modify the? Let me see if I can modify this instead. You let's just comment it so that we can start with something fresh. Okay, so now the example the example I want to use here is what I'm about to demonstrate, right? So we have age, so I'm initializing it. So over here our age is 20, right? Now let's also introduce something interesting. Bool. So let's see has ID, yes, has ID, has ID. Now bool statements only take true or false. So in this case, let's just use true. Okay. Yes. So we initialize the age as 20 and has ID is true. Has ID is true. Now let's see how our nested if statement works. So our first if statement is if the age is greater than or equal to 18. Yes, greater than or equal to 18. So greater than or equal to 18. 18. Why did you give me 18? Okay. Then right away we introduce the other if statement, right? So as I mentioned earlier on, after you introduce an if statement, right, the next, how do I say, the the statements, the next statements, or the other statements are enclosed in a curly brace. I mentioned that earlier on. So the same principle applies for nested if statements. So your outer if statement, right? Then you introduce the curly braces. Then you put in your inner um nested your inner if nested if statements. Yes, your inner nested if statements. So in this case, what will be your inner nested if statement? Has ID. If has ID because we initialized two data types over here, int and bool. So has ID, right? So over what um this will do is that it will consider these two statements or these two conditions before giving you an answer, depending on the expression or statement that follows, right? So when now we've done our two, or we've given our two if statements, so what will be our following statements? So let's move on to that. Sorry, let's So right now we are considering the inner if statements, right? We want to consider the inner if statements before we move to the outer one. So right now the inner if statement is saying that if has ID. Now over here the has ID is true. So if has ID, then let's introduce our compound statements inside, or our statements that would correctly suit the condition over here. So if has ID, then you can enter. If you have an ID, you can enter. So where's the exclamation mark? Okay, yes, you can enter. So that's our first, you know, um, condition answered, right? Else, else because it's a nested if else. It's not a nested if statement. It's a nested if else statement. So we will introduce our else as well. So this is our first, you know, answer to the condition has ID. Has ID. So if the person has ID, person can enter. Else see out you. Uh, sorry, let me in the double quotes. You can enter. Let's put enter here. Cannot enter. You cannot enter. You cannot enter. Yes. So what we've done here is that we are saying if the person has ID, person can enter. Else if the person doesn't have ID, person cannot enter. The person cannot enter. Then we move on to the outer if statement. We give an answer to that condition as well. We give an answer to that condition as well. So then we come back. We come back. We come back. We come back. Else, else, else. So this else here is for the outer if statement, right? So we are done with the inner if statements. Now the inner if statements. Else, else. Then we introduce our um statements to answer the condition. Else, so if the person is greater than or equal to 18, then the person is too young. Person is too young. Greater than or equal to 18, the person is too young. So let's see. Let's see. So see out too young. So yes. So what we've done here is I've basically explained it to this point. An inner if statement and an outer if statement. And we provided answers to all the conditions, right? So let's see if this code work. Let's see if this code will work. It's giving us an error. It's giving us an error. Okay, so funny enough, we did not bring age. We did not bring age into this parameter over here. That is wonderful. So let's quickly do that there. Age. Yeah, so that's what the error was about. We did not bring age. What we are comparing, we didn't even bring it there. Wow. Okay. So let me space it out a bit. Okay. So let's see if it's run. Oh, there's another error. Okay, let's see. Let's see what the error is about. So there's a comma down here, right? So you need to. It's not always that after writing the code you can get it running. You might make one or two errors, so you need to be very careful when you are writing the code. So I think I've corrected that error as well. There was a comma instead of a curly braces. I think my eyesight is not really that good, so you can enter, right? So per the condition you give, right, that if the age is greater than or equal to 18 and the person has an ID, the person can enter, right? Now let's check the situation whereby the person is less than or equal to 18, less than or equal to 18, less than or equal to 20. And mind you, the age cap we, you know, introduced there was 20, right? So it can't exceed 20. So let's check that too. Let's check this. If the person is less than 18, too young, too young, right? So that is nested if statements. Let's move on. Switch statements. Now, switch statements allow you to choose between multiple alternatives. They allow you to choose between multiple alternatives, so you can think of switch statements this way, right? So it lets you, you know, compare one value against multiple possible matches and execute different code blocks for each case. So let's use this scenario by here. So let's say you are at an ice cream shop, right? And then you have three options of ice cream: vanilla, chocolate, strawberry. So option one is vanilla, option two is chocolate, option three is strawberry, right? So a switch statement is like, telling the cashier your choice number, and they give you exactly the flavor you ask for or exactly what you want. So if you choose vanilla, the cashier will give you vanilla, right? If you choose chocolate, the cashier will give you chocolate. If you choose strawberry, the cashier will give you strawberry, right? And the cashier wouldn't have to, check each option you choose one by one before picking the one you choose. The cashier knows that you choose option two, so it will bring you option two. It doesn't have to check what option one and option three were. Uh, so that's how switch statements work. So what is the syntax of a switch statement? So the syntax of a switch statement is keys sorry your switch then the expression switch then the expression then your curly braces. Then within this curly braces, you have your compound statements or your following statements. So your case, then your statement, then you break it. Then your second case, your statement, then you break it like that. So for the number of cases that you want to actually perform, uh, so it will go on for the number of cases that you want to perform. Then when there is no output for any of the options, then you introduce this default in your statement. What this means is that once any of the options are not available, then your default statement will be what will be displayed. Yes, that will be what will be displayed. So you can see more illustrations on this over here as well. And then a typical example over here as well. So let's go on to show that practically. Now, now we are about to demonstrate how the switch works. So let's comment over this. Now let's move it down. Now first initialize. Okay, so in this case, day. Let's say day here. Day, day. Then let's have 3 days. Let's have 3 days. 3 days. Now the syntax was what switch, right? So switch. Then your expression in a bracket. So in this case, the expression is d. D. The expression is basically what you initialized, right? So D, D, then our curly braces, then our first case. So in this case, case one, that is D1. Yes, we are having 3 days. In this case, we are doing 3 days. What I'm doing is that I'm about to compare um 3 days, right? Now the right day would be day 3. The day I'm looking for is day 3 because that's what I initialized by here. That is int days equals 3, right? So I'm about to give different options, right? So different options with the corresponding statements. So if it is day 3 or if the system checks and it is day 3, right? I'll let it what output a message to me that okay, maybe day 3 is let's see Wednesday, or day 3 is Thursday, or day 3 is Friday, right? So that's what I'm doing. So let's move on. So our first case, that is day 1, right? So if the day is 1, or the day is day 1, then this will be our statement, or this will be what the system should output for us. See out, let's see Tuesday. Let's see Tuesday, Tuesday. Okay, Tuesday. So if the day is day 1, then Tuesday will be displayed. Tuesday, okay. Now, what do? We break, move to the next one, right? And yes, we breaking it means that we once it considers case 1, if it's not case 1, it stops, then moves to the next case. That is what they break. That's why they break it there. That is why they break it there. So let's move on to our case two, then our column, then if it is day 2, if it is day 2, right, then our console should output this for us. Wednesday, Wednesday, Wednesday. In Kelly, sorry, in double quotes, yeah. And you also make the W capital so that Yes. Then break. Then move on to case 3. Then if it's just case 3, which is the answer we are looking for, or D3, then the system should output Thursday, 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 yeah, Thursday. Then we end it, right? So we've gotten all our 3 cases. We've gotten all our 3 cases. We've gotten all 3 cases. Now let's go on ahead to break this one as well. So we break it. Then, as I mentioned earlier on, should in case all these cases appear incorrect, right? Then we want our system to display an error message, right? An error message. How do we do that? That is where the default comes in. Default. Then um, we tell the system what message it should display at the console. Should in case all the options were not chosen or all the options are wrong. So our colon, then see out. So this is our error message, right? Let's say invalid option, or no, invalid D. Yeah, invalid D. Let's use D. Invalid D. Then semicolon. Then we finally close the curly brace that we opened a long time ago. We finally close it now. Okay, so our output should be Wednesday, or our output should be Wednesday, because we initialize the day as 3, that is day 3, and day 3 in our cases is Wednesday. Day 3 in our cases is Wednesday. Day 3 in our cases is Wednesday. So let's see if there will be no errors. Hey, Thursday, yeah, Thursday. Sorry. The 3 is Thursday. The 3 is Thursday. Yes. The 3 is Thursday. Let me show you. The 3 is actually Thursday. Very sorry. I don't know why I made that mistake. I kept thinking that the 3 is Wednesday. Okay. So the day 3 over here is Thursday. Yes. So our answer should be Thursday, not Wednesday. Yes. So let me write it again. So Thursday is our answer. Yes. So yes, that is how the switch works. So the syntax is your switch, your expression in the bracket, introduce your curly braces, your first case, then the message or the statement that comes after that, then you break it. Then your second case, then the second case statement, then you break it. Then your third case statement, then you break it. Right? The breaking is very important, because once the system runs through, sees that it is not case 1, it will immediately stop there, move to case 2. If it's not want to stop there, move to case 3, right? If you don't break it, it will just continue like that. So it could even execute case 1 and case 2 together. Yes, if you don't introduce break, right, it can execute case 1 and case 2 together or at the same time. Yes, depending on the condition. So that is uh, switch. Yeah, that is switch case statements. Yeah. So as I mentioned earlier on, the break exits from a switch or loop immediately, right? So it can be used to jump to the first statement that follows a switch or a loop. I've already demonstrated how break works. I demonstrated how the break works. So then there's a continue statement. The continue statement continues execution after a condition is accomplished. It's used in loops and has the opposite effect to break. So basically, continue is the opposite of break, right? Continue is the opposite of break. So what break does? Continual does the opposite of what break does. So that is also the sentence over here, right? So in this case, instead of writing break over there, just replace it with continue. Instead of writing break, just replace it with continue. Now let's move on to operators. Operators, they are mathematical symbols or arithmetic symbols for operations. So we know the plus, minus, the question mark. The question mark is actually called a conditional operator, and then our division or you know greater than, less than, all that. So there are types of operators. We have arithmetic operators, we have assignment operators, we have conditional operators, we have relational operators, we have logical operators. Now, arithmetic operators are the ones we know, right? Modulo, addition, subtraction, multiplication, division, yeah, basically that. So a unary operator has one operand, a binary operator has two operands, a ternary operator has three operands. Right? You know what operands are? They are what the operators are working on, right? So for instance, if you have A plus B, A and B are operands, whereas the plus is the operator. Now, logical operators. For logical operators, they are used to express logics. So we have uh, the double ampersand, the double bar, and then the exclamation mark. Yes. So what what they do is that they return a Boolean result that is either true or false, right? So the syntax is what is given over the expression, the operator, the variable. You throw more light and more light on that as you go down. So an example is over there. So y is for x as an expression, and the operator comes in between them, then y as the variable, right? Or x over here as well, and this operator, then the y. Okay. Now, the double ampersand means and. So in a logical operation or in any logical operation, you see a double ampersand, then it's referring to and. So over here, an example is given. So if age is greater than or equal to 12 and age is less than or equal to what 18, I have read it out in English terms or in terms of English. But um the double ampersand means end. So you should keep that in mind. The double ampersand means end. Then we have our or operator, our or operator. So the or is a double bar, a double vertical bar, right? So if age is equal to 18, right, or age is greater than 18, that is how it is read. So our or is the two bars, the two vertical bars. End is the double ampersand, or is the vertical two bars. So these are they are mostly used in if statements or iteration statements, right? You should take note of this. These logical operators are commonly used in iteration statements because since iteration statements literally or basically return whole results, that is true or false results, and the logical operators also do the same thing. They work hand in hand to make our iteration statements meaningful, right? They work hand in hand to make the iteration statements meaningful. So in case you want to compare two things, right, two conditions, right, we introduce the logical operators. So over here, we were comparing uh, age 12 to age 18, right? So we got end, right? So it's kind of a comparison, right? So if age is greater than or equal to 12 and age is greater than or equal to 18, so this is kind of like a comparison and also a kind of interval, right? We've given a kind of interval for the age. So greater than or equal to 12, less than or equal to 18. So any age that falls within this range, so that's the power of the logical operators. Over here as well, we were comparing these ages here, right? So one being 18 and one being greater than 18. So age being 18 or age greater than 18, right? So that is the power of the logical operators. And we have the not logical operator, not. So should in case we like to say that an age is not equal to a certain age, right? So in comparing over here, we are comparing these two ages, 12 and 18, right? 12 and 18. We are comparing them by saying that the age 18 or the age should not be equal to 18. The age should not be equal to 18. We said that the age is equal to 12. Now we are here saying that the age should not be equal to 18. So it's a comparison we are making, right? And then how are we doing that? By using the not logical operator. So by attaching the not logical operator to our assignment operator over here, then we've basically said that the age is not equal to 18. That is how the not logical operator also works. Then we have our conditional operators. We have our conditional operators. We have our conditional operators. So basically conditional operators are like a shortcut for if statements. They are shortcuts for if statements, right? So instead of writing, um, our normal if statements that we have written, right? We can shorten it using a conditional operator. But we can shorten it using a conditional operator. When I was explaining what the conditional operators are, I said they are shortcuts for if statements. I mean if else statements. Conditional operators are shortcuts for if else statements. They are shortcuts for if else statements. They are shortcuts for if else statements. So um let's go on ahead to look at the syntax, right? So the syntax is as follows: the condition, then the conditional operator, then the first expression, and then the second expression. So the condition, the conditional operator, the first expression, that is the expression if true, and then our column, and then the expression if false, that is the expression two, right? So um an example is over here, right? So results, results, results. Now what are we saying? We're saying that if the results, okay, should follow this condition over here, that is x is greater than or equal to 0, then the conditional operator, okay, the x can be true or x can be equal to 0, okay, or and x can not be equal to 0 as well. I don't know if you understand what I'm saying. Okay, so let me try to give a clearer example. Let me try to give a clearer example. Uh, Let me demonstrate that through code. Okay, so let's comment on this. So comment on this as well. Okay, so now let's say um we want to find the maximum value, right? The maximum value here. Let's use that. So we want to find maximum value between two numbers, right? Or two variables. Okay. So we first um as int max. Okay, so int max, then our assignment operator, right? So that is the syntax for the conditional operator. So our condition comes first. Our condition comes first. So a greater than b. Okay, it can be less any. I'm just using any example. So a greater than b, right? Then our conditional operator, that is the question mark. Where is the question mark? Yeah, over here. Okay, question mark. Then the expression one, then our colon, then a yeah, colon, then expression two. Okay, so now what this statement means, okay, this very statement I've done here, okay, we can also type the same thing or write the same thing down, okay, using if else, the concept of if else, but that would be more lengthy to be longer than this, right? So the conditional operator has, cut it very short for us. So what this single line of code means is that now we are saying the condition is that a is greater than b, right? So if a is greater than b is true, if a is greater than b is true, then max, okay, can be equal to a. Max can be equal to a. If a greater than b is false, then max can be equal to b. The max can be equal to b. That is what this single line of code means. Okay, so this first expression here basically means that if the expression is true, then max is equal to the expression that is the first one. And then if the expression is false, right, then max will be equal to the expression of the second one. Okay, or the expression of the second expression, yes. So that is what is the conditional operators, or that's how the conditional operators work. Let's move on to increment operators. Now for increment operators, they are used to express increment in value usually by one. They increase the value by one. Now there are two types of increment operators: the prefix increment and the postfix increment. The prefix increment and the postfix increment. Now how do they work? Well, for the prefix increment, it's say if you give a value, or if you okay, let me just show you practically that that's a very better way of letting you understand how this thing works. Okay, so now this is pre-increment, right? Pre-increment increments the value, then displays it. It increments the value, then displays it. So let's initialize the value. So it's age, say 22, right? Then we terminate it. So now we know age is 22, right? Now I can go on ahead and increment the value of the age, or increase the value of the age. So I can do that by using prefix increment, right? So in this case, I'm using prefix increment first so that you see. So for prefix increment, you put a double plus, then age, right? Okay, you let me change this age to a letter so that it will make more sense. Let me change it to X so that it will be more simple, like, yeah, simple class. So int x we've initialized x as 22. So now the system, or we've allocated a memory, okay, a memory uh, for x in the system that is storing the value 22. Okay, so now we want to increase this value, 22, right? So we are using prefix increment. So we just simply come down here, then double plus x, then we terminate it. So by doing this, right, now the system will immediately change the value of x to 23 and print it out. So it will immediately change the value, that value, from 22 to 23, and it will print it out. So the output over here will be 23. That's prefix increment. So it increases the value and then prints it out. It increases the value by 1, then prints it out. So let's print it out and see how it turn out to be. So x, what will be our value for x now? Let's see. So 23. So you can see that is how the prefix increment works. It increases the value by 1, then prints it out. Okay, now let's see how post increment works. Post increment works. Let's see how it works. So right now let's take this off. Okay, let's take this off. Now for post increments, let me demonstrate something to you. So what post increments, um, you know, does is that instead of changing the value, okay, or increasing the value by 1 and printing it out, just like how the prefix does, it doesn't do that way. Okay, as the name suggests, post. So it will first display the value, the old value, the value that the system has temporarily stored. That is the 22 over here. It will display the 22 before it will what? Increase the value of 22. It will first display the 22 before it will what? Increase the value of 22. Please keep that in mind. It will display the value of 22 first. In this case, we are dealing with 22 over here. It will display 22 first before it will increase it by 1. Before it increases it by 1. So let me demonstrate that to you. So right now, you see for the prefix, once I initialize this and then did the prefix increment, it immediately or instantaneously increased the value to 23 when I decided to display it in the terminal. But let's see if it will do same for the post increment. Yes, the post increment. So after the post increment, you first bring x, then double plus. Let's see if it will display. So which is, hold on. Yeah, so that was not what I was supposed to actually show you. Yes, there was a mistake when I was doing the thing, right? What I wanted to show you was not what I did. Yes, like I made a mistake. Yes, so let me correct that mistake so that you see. Okay, so I was not supposed to bring this first. I was supposed to bring this first. Okay, I wanted to show you how the post increments really works. So in order for you to see how it really works, I'm not supposed to bring it here, right? I'm supposed to let the system rather display it for us before. Okay, so right now let's do this first. Okay, let's see how the pre-increment would respond to this. Okay, so let me change this to pre-increment runner. So plus plus then x. Okay, let's see if the system will increase this value by 1. This is pre-increment. We are doing pre-increment first. We've already done it, but I want to draw some kind of fine line between pre-increment and post-increment. So let's uh, pre-increment the value over here. So you see the value increased to 23. The value increased by 1. Okay. So the pre-increment, as I explained earlier on, it will instantaneously increase the value and then display the value that it has increased. Okay. It will instantaneously increase the value by 1 and display it. Okay. So that's what it does now. Now let's see if it do the same for post increment. Mind you, post increment, the value will not be increased, but rather the initial value will be displayed before it is increased. It will be displayed before it's increased. So let's see if that is what will happen. So over here, you can see it is still 22, right? It did not increase 22. The reason being that for post increment, it will first display the old value or the value that has been temporarily stored, right? That is the 22 before it will proceed to what increment or increase the value, before it will proceed to increase the value by 1, right? So let's proceed to now increase the value by 1. Let's see. So now come and then do this. So initially I was supposed to bring this here. So now that I've got this here, let's see how the system would react. So you see it has increased the value by 1. So that's post increment, right? It will first display the old value, then we'll increase it afterwards. Okay, first display the old value, then it will increase it afterwards. So that is it for post increments and pre-increments. Under increment operators, the same principle applies for decrement operators as well. There are also two types: prefix increment, post-fix increments. They are basically is the same logic behind, yes, the same logic behind the increment operator. That's the same logic the decrement also uses. Now we have operator precedence. So they are in this order: multiplication, division, and modulo. They are at the same level of precedence, so they are evaluated on the same level. Yes, they are evaluated on the same level, right? So um, we have addition and subtraction also following them, right? And mind you, the multiplication, division, and modulo are not the first level, right? There's actually the bracket. So the bracket is evaluated first, right? It's like board mass from primary teachers, right? So the brackets first, then division, multiplication, modulo comes second, right? So these three are evaluated on the same level, and then the last ones to be considered are the plus and then the minus, the plus and then the minus, the plus and the minus. They also have the same level of precedence, but they are evaluated last. So that is it for week 4. That is it for week 4. That is it for week 4. So look forward to week 5. Yeah, look forward to week 5. All right, so catch you in the next one.